Here's an example of a combined transformation of the sine function. If I have f of x equals 2 sine 2 times x minus pi over 2, all plus 1, I have it already in the form of a sine b times quantity x plus c plus d. I know my a is 2, so I'm going to be stretching like this. I know my b is 2. My b is 2 means I have 2 cycles from 0 to 2 pi with the sine curve. And I also know that my period is 2 pi over b, 2 pi over 2. My period is pi, 1 cycle from 0 to pi. My c is negative pi over 2. That means I'm going to move this graph over pi over 2 that way. And my d says shift us up 1. Through video magic, we can see this is the graph of that curve. I was asked to stretch it, so now my amplitude is 2. My d said move it all up, so my center line was at 0, now it's up at 1. I shifted over to the right, so this point went over to the right. And I have 2 cycles between 0 and 2 pi. That means each cycle is just 1 pi. That's pi over 2 to 3 pi over 2. Yes, that is a distance of 1 pi. You would keep on going with this graph. I just drew 1 cycle here. Consider the combined transformation of cosine. Here's our function. F of x equals negative cosine 1/2 x minus pi over 3 plus 2. Well, we know that this negative means we're going to flip this curve over the x-axis. This 1/2 is the b term. It's multiplying by x minus c, or x plus c. So this is going to tell us, our b tells us that there are 1/2 cycles from 0 to 2 pi, and we know that our period is equal to 2 pi over b, so 2 pi over 1/2 is 4 pi. So 1 full cycle is 4 pi. A minus pi over 3 says move it this way, pi over 3, and a plus 2 for your d term says move it up 2. For the purpose of our exercise, let's just consider the flip first. A 1 will go to -1. And let's consider now that our period was, for the parent function here in black, we had a period of 2 pi. This 1/2 of the b term caused our period to go to 4 pi. So I flipped it, positive goes to negative, and then I made my period 4 pi. 1 cycle from 0 to 4 pi. Well, to finish this, I'd have to move this whole blue graph over to the right, pi over 3, and then my center line would go from 0 to up 2. So my graph would really be over and up when I finalize it. Finally, let's look at a third example of combined transformations, this time for the tangent function. If I have f of x equals negative 1/2 tangent 1/2 x minus 1/2 pi, there's no d term, so you can say plus 0. I know that this negative means I'm going to reflect over the x-axis. So if my tangent function was like that, I'm going to have to reflect it. So this point goes to there, and this point goes to there. The 1/2 is going to make me squatter. If this was a 2, I'd be stretching the function out. But here I'm actually going to be squishing it down towards the x-axis because of that 1/2. Again, amplitude doesn't mean much with the tangent function. Here's the key. Our b term that's going to multiply whatever's in parentheses in front of the x here is 1/2. So we know that our period is pi over b. Not 2 pi over b with a tangent function, but rather pi over b. Pi over 1/2 is the same as pi times 2, which is 2 pi. So we'll have 1 full cycle in 2 pi. And the key that I start with always with the tangent function is we have 1 cycle from negative pi over 2b to pi over 2b. Well, if our b is 1/2, I can multiply 2 times 1/2 and I get 1, and 2 times 1/2 and I get 1. So I know I'm going to have 1 cycle from negative pi to pi. So that's where I start my amplitude, my horizontal, my vertical asymptote goes at negative pi, and my other vertical asymptote goes at pi. So I can draw my function here. It's going to be squat, and it's going to be flipped over the x-axis. Now, that would be this function here without any horizontal transformation. I have to add in a negative pi over 2, which is going to push me this way. So I take this whole graph and I move it over pi over 2. So this isn't our final answer. I still have to account for that, but you can do that on your own.